I'm Ashwin Vasavada, project scientist for the Mars Science Laboratory, and this is your Curiosity Rover Report. Curiosity has completed its second Mars year at Gale Crater. I know what you're thinking. Didn't Curiosity land 4 years ago in August 2012? Well, those were Earth years. Since Mars is farther from the Sun, it takes nearly twice as long to make one circle around the Sun. Each Mars year lasts 687 Earth days. Even though Curiosity may be better known for driving around and drilling into rocks, it has quietly been compiling a comprehensive almanac of the Martian weather. For 2 full seasonal cycles, scientists can figure out which events occur year after year and which ones are unique. Mars has seasons, just like Earth. The similar tilts of Earth and Mars give both planets a yearly rhythm of seasons: spring, summer, fall, and winter. But there are some big differences. Temperatures in Los Angeles are pretty warm all year long, and they don't vary much between daytime and nighttime. But Mars is much further from the Sun and has a very thin atmosphere, so temperatures at Gale Crater are really cold. In the middle of summer, they're almost bearable for us human beings, but in the middle of winter and at night, they reach minus 130 degrees Fahrenheit, or minus 90 Celsius. Curiosity has measured water content and relative humidity over the Martian seasons. Even with this tiny amount of water, if temperatures get cold enough, the relative humidity goes up, and you can get clouds on the sky and frost on the ground. In the middle of winter and at night, relative humidities can reach as high as 70%, but so far, Curiosity has not detected any frost. Curiosity's long seasonal record also has given scientists some new clues to understanding methane in the Martian atmosphere. Curiosity saw a large spike in methane during its first year on Mars. It didn't repeat the next year, so we can rule out a seasonal cause. But there is a lower, background level of methane that does seem to vary with the seasons. Methane may be produced by microbes, but may also result from a number of non-biological processes. Other seasonal patterns have now become apparent as well. For example, spring and summer at Gale Crater are dusty, but in the fall and winter, the air gets remarkably clear. It's been a great 2 Martian years, and here's looking forward to a third. I'm Ashwin Vasavada, and this has been your Curiosity Rover Report. Please check back for more updates. It's a summer of milestones for Mars exploration. 50 years ago, Mariner 4 became the first spacecraft to take close-up pictures of Mars. 39 years ago, the Viking 1 lander became the first spacecraft to successfully land on the Red Planet. And now, Curiosity celebrates 3 years on Mars, operating well over 1,000 Martian days. Since its arrival in August 2012, Curiosity has driven nearly 11 kilometers from its landing site to the foot of Mount Sharp within Gale Crater. The first year was spent traversing through ancient streambeds and exploring Yellowknife Bay, the site of an ancient lake. That's where Curiosity drilled samples from the lake floor to reveal mineral evidence of long-lived fresh water. It also found carbon-containing organic molecules and nitrogen in a form usable to life. So, if life ever were present on Mars, a site like Yellowknife Bay could sustain it. Then Curiosity put the pedal to the metal to get to Mount Sharp. That's when engineers noticed excessive wear on the rover's wheels. A lot of work went into understanding the cause and how to avoid it. But now we're confident that the wheels can take us where we need to go. It's been quite a road trip. Curiosity drilled at the Kimberley, drove through long valleys, and took pictures of roadside geology before finally reaching the bedrock at the base of Mount Sharp. We spent several months studying these rocks at Pahrump Hills. The science team has been fascinated by all the signs of ancient water at Mount Sharp. It's likely that Gale Crater once hosted many rivers and lakes, carrying sediment to the crater floor that now forms the bottom layer of Mount Sharp. Now that we're climbing through the foothills of the mountain, the driving is challenging. The team relies on images from the Mars Reconnaissance Orbiter to find safe paths to interesting geologic targets. Getting to the current rover location at Marias Pass required a steep climb up a 6-meter hill. As we climbed the hill, Curiosity's ChemCam laser spectrometer noticed unusually high amounts of silica in nearby rocks. What might that mean? Were the environmental conditions friendly or hazardous to life? Could the silica have preserved organic molecules in the rocks for us to study today? We're hoping to find out. None of this would be possible without the dedicated team of rover engineers here at JPL. Every day that we operate Curiosity, a downlink team studies the information sent by the rover and makes sure it's healthy and ready to proceed with the next activities. Then, an uplink team turns the desires of the scientists into sequences of commands that can be safely executed by the rover. It's an intense process that takes about 9 hours every day.
Hi, I'm Marissa Hines, one of Curiosity's rover planners, and this is your Curiosity Rover Report. Imagine you're about to take a road trip, and you want to travel from, let's say, Atlanta, Georgia to Los Angeles, and you have a week to get there. Well, you have to decide what roads you want to take and what stops you might make along the way, what things are most important for you to visit. Curiosity has a similar situation. Here is a zoomed-out picture of where we are at Gale Crater. Pahrump Hills is up here at the top of the map, and eventually we have to cross over the Bagnall Dunes at this area and get across to the clay and hematite ridge that we want to study at the base of Mount Sharp. One of my jobs as part of the Strategic Route Planning Group is to use the orbital data that we have available to help find routes that are safe for Curiosity to traverse and allow the scientists to visit the things they find interesting. From there, the Strategic Route Planning Group developed a series of routes that we could review to find what we thought the best routes were through the corridor. On the highway map, you can see two different colors of routes. The white routes are the routes that the strategic group believes are the best for Curiosity's wheels. The black routes provide other options that allow the science team to get into more rugged terrain that we still think is safe and traversable for the rover. The science team decided after exiting Pahrump that the next place they really wanted to go was Logan Pass. So that allowed us to take the white route that we've now called the Lewis and Clark Trail. This red dot on the map represents our first opportunity to get a really good view of the southern region, so we stopped to take a really nice mass cam mosaic of that area. What makes Logan Pass really interesting is apparent in this mass cam image. You can see two distinct layers that come in contact with one another here at Logan Pass. The bottom layer being the Murray Formation, and the top layer being what we've called washboard that's been identified from the orbital imagery. After spending some time studying Logan Pass, Curiosity will get back on the Lewis and Clark Trail and head on down the road to its next destination. This has been your Curiosity Rover Report. Check back for more updates.
Hi, my name is Katie Stack, and I'm a Curiosity Rover mission scientist here at the Jet Propulsion Laboratory, and this is your Curiosity Rover Report. After 2 years and nearly 9 kilometers of driving, we finally arrived at the base of Mount Sharp. Before we even arrived at Gale Crater, we used our orbital images to begin our exploration of Mount Sharp. What we found was an important boundary, separating the sediments of the Gale Crater floor and the layers of lower Mount Sharp. The rover is now here at this important boundary. An earlier path to Murray Buttes would have delayed our arrival at lower Mount Sharp. However, a couple of months ago, we decided to take a different path because it was more scientifically interesting, and that brought us to Pahrump Hills, where we're encountering the rocks of lower Mount Sharp nearly 2 kilometers before we originally expected. This bright outcrop is Pahrump Hills. It's about 15 meters across. At this location, we're looking forward to obtaining our first drilled sample of lower Mount Sharp. And while we're excited about what we may find here, our exploration of Mount Sharp is really just beginning. As originally planned, we'll be exploring Mount Sharp layer by layer. Along the way, we'll be encountering a number of interesting geologic features where we're looking forward to continuing our search for ancient habitable environments in Gale Crater. This has been your Curiosity Rover Report. Check back for more updates.
Hi, I'm Jennifer Trosper, the Deputy Project Manager on the Curiosity Rover, and this is your Curiosity Rover Report. We landed on Mars over 1 Mars year ago with the purpose of studying Mount Sharp. We've driven 6 miles to get to the base of this incredible mountain. Exploring the foothills of Mount Sharp is like turning a history book page by page. As we look at each layer, we want to know what formed and deposited these layers and how are they related to each other. We also want to understand the potential for organic preservation in each of these layers. In preparation for drilling, we did some testing here in the Mars yard to understand how changing some of our drill parameters could help us be more effective at drilling softer and more breakable rocks like the ones we see at Pahrump Hills. We perform a mini drill on an adjacent rock, usually to understand the properties of the material we'll be drilling. Then we do a full drill, and if we confirm the sample won't clog our sample collection system, the next step is to transfer it to the instruments for analysis. Since it's such an interesting location, we expect to spend several weeks here systematically studying the rocks layer by layer. This has been your Curiosity Rover Report. Check back for more updates.